Today we're going to talk about chapter 9 in your textbook, and it's about different kinds of queries we can do with spatial data using explicitly spatial queries. And so there's a couple functionalities and tools that we'll talk about. So a query is one way of thinking about it is a selection, and we looked at selecting, right? Pressing Control Shift and then clicking on different polygons to select them, and then we merge them together in the editing session, right? Now we are going to be doing selections in a different way. We can select things by using attribute information. So here in this case, there's a county shapefile that has population data, and we can run a query to select all the ones that have population greater than, in this case, 100,000. You can then use that selection to extract a subset of the data, save it as something else, another shapefile for different kinds of analysis. And then, of course, you can do different kinds of symbology as well. So this is an attribute query, and then we can also do spatial queries where we have relationships of two different shapefiles or layers, and we're going to select something in one layer based off another layer. So in this case, they give an example of parcels that are in a floodplain. Okay, we've got a floodplain, which is a big polygon around a river, and then we have parcels or property parcels that intersect that, right? So that's a spatial type of query we could do. So it's just some other examples. We can select features of interest, wells with high iron concentrations. That would be an attribute data type of query. We can look at spatial patterns. So where are gold mines versus other types of mines? Are they near each other? So you can kind of do a buffer type of analysis. We can separate out different types of data. So isolating features for more analysis. So I got this huge data set. Well, and we did this with the bridges, right? We have this huge data set of bridges, but I only want to select out the ones that I'm really concerned about. So we had some criteria, and we separate that out. And then you can export that as a new shapefile then to do other things. Spatial relationships is what we just talked about. So how does one thing relate to another? The other example they gave is roads crossing limestone outcrops, where you might have potential pollution in groundwater. So limestone's porous, connection with the aquifer. And so where could we have spills that could damage the aquifer or contaminate the aquifer? We can also do raster queries. And this is, and we won't talk about rasters today, but you could say, okay, here's a raster, and I want to just get out everything that's above a certain elevation or below a certain elevation or something like that. So essentially, we're looking at a data set, a spatial data set, and we're using different tools, either in the data themselves, the attribute table, or spatial relationships to select a subset of those data. All right. We can use operators, greater than, less than, plus, minus, that sort of thing, and or not. And we've done some examples of this last week. And this would be spatial data, or basically in the attribute table. And then we have spatial operators. So intersects with, is near, within so many feet or miles, is totally contained within. So there's a lot of options we have for that. So the first type of queries, and we've done a little bit of this, is attribute queries. And what they're doing is something a little bit different, which is the select tool. So I'm going to open ARC real quick and we'll look at that. So I opened up this Colorado Bridge map that we worked on last week. And last time you'll remember that we selected bridges based on, we went to properties and we did a definition query. And we set up this query where we had, we did a spatial join and said, okay, tell us where we have more than 5 bridges that were in poor condition. So that was just a query that we did based on the attribute table, and it just displays then the ones that the shapefiles or the polygons that meet that criteria for the selection. Now, what we're talking about today is a little bit different. So it's under the selection pane right here. So there's a lot of different options we have for selecting things. We can just do manual selection, where the default is a rectangle, and I can draw a rectangle and then select things that fall within that rectangle. So that's one thing to do. And you'll note that when I select in the attribute table, it shows things that are selected as well. And I can show all records, or I can click on this and just show the selected records. So if I have 10,000 things and I select 100 of them, then this makes it a little bit easier to look at just 100 things. If I go into the attribute table and I want to do any calculations, say, for example, I want to make a new code, and I'm going to say, okay, here's a new code, and these are the bridges that I really care about. And I'll calculate the field, right click on that header, calculate the field, and then I can give it a different code or name or something like that. That will only apply to what I've selected. It won't apply to all these other shapefiles. So that's just a little thing to know when you're dealing with selections. So that's a manual selection. There's different tools, right? I can do a polygon and trace an area around a feature that I want to select. I can do circles. I can select by attributes, and that's one of the things we're talking about. So this is exactly the same as this definition query. So it's only based on the attribute table. So I want to look at the county boundaries. I want to do a new selection. Of course, there's other options, right? I can add to a current selection. And then I do an expression. And this is the same that we did before. So maybe I want to say, okay, I don't know. There's not a lot of information here on the county, so I can't tell you much, but you could do a query on the county based on the attribute table. I press apply, and then it would select the, all right, I don't want to actually do this. Can I get out of here? Okay. And then it would select the counties for which that definition query applied. So the only difference between what we did last week and this week is that instead of only displaying the features or the elements within the shapefile that fall within that definition query, now we're selecting them. We're selecting the ones that apply, and then you can do other things like, okay, let's just export, do some calculations just based on those, something like that. So that's selecting by attributes, and then we have selecting by location. So I'm going to do our county boundaries again, and oh, sorry. Yeah, I want to select. So input features would be, what do we want to select? The relationship would be intersect. We could have contains. We could have, so intersect just means they overlap. We could do within a search distance, right? Decimal degrees isn't going to work because that's a little awkward. So maybe we do feet or miles. And let's see. I don't know the answer to that, but I bet you it's in your book. There's contains, completely contains, and then within. Yeah, I don't know what the difference is. Within a distance, that's pretty clear, right? So search distance, let's look for something that's within, 1 mile, right? This would make a little more sense for, say we had a river polyline, right? And we want to search for the homes, say you had a dot for each home. What are homes that are within a mile of a river? So you could select that way. I've used that tool a lot. So the input feature is what you want to select. I'm going to do the bridges, and then the selecting feature would be what you're going to use to select this feature. So I want to find, this is kind of a weird example, but we'll just say I want to find bridges that are I'm just going to do contains. And I'll take that search distance out. So bridges that are contained by a county. And right now, we'll do the Yeah, well, it's probably going to select all of them because they're all. I'll think it like that 0 miles. Input features, statement of the bridges, new selection. Let's try that. No, didn't like that either. Okay, so we got some error messages because we have to make sure that, for example, a point can't contain a polygon, that kind of thing, right? So in this case, we looked at the distance, right? That's kind of a weird thing to do for counties, but let's just let's see. Let's give this a name again and see if we can do something with that. Okay. So there's tools to select different things based on where they are spatially. Are they within? Are they near? That kind of thing. All right. Continuing on with the discussion about spatial queries, which I think is going to be the most pertinent for this lecture because we've looked at doing queries with attribute tables. We've got a lot of ways to do this. So we can do counties that contain volcanoes, counties that intersect rivers, parcels in the floodplain, cities within 50 miles of a park for that amenity type of feature. And here's a breakdown of all those different types of spatial operators that we can use. So intersect, test whether they touch, do they overlap, contains or within, test whether they're inside one another, and then proximity is whether they're within a distance. There's a lot of other different options out there as well. Okay, within contained, we have completely contains. So it does not permit a shared boundary. So for example, here are the counties in Oregon, and the blue ones are the only counties that are completely contained within the state boundary of Oregon. So they don't share a boundary. The target layer is the one that you're going to be selecting, and the source layer is the one that you are using to do the selection. In this case, the counties are the target layer, the counties are selected, and the volcanoes are the source layer. So we're selecting counties based on the location of volcanoes. And that's the select by location tool that we're looking at. Here's another example. So counties input feature. So we're selecting counties that intersect with rivers. And so we have a national map of kind of major rivers in the country. And here's all the counties that intersect those rivers. Counties that contain volcanoes, counties that intersect rivers, and cities that are within 50 miles of a volcano. So in this case, we selected a point, so city points based on proximity to volcanoes. There's some other examples, rivers that intersect Texas. So here's the state boundary of Texas, and here's all the rivers that go through it. Counties within 50 miles of a major airport, and then states that border Nebraska. Go Huskers. All right. So some of the challenges with spatial queries, just to be aware of them, is that you're selecting what exists. In this case, we selected rivers that go through Texas. We didn't clip rivers to Texas, right? That's a different thing to do. So clipping is actually splitting up shapefiles based on another shapefile. Here we're just isolating, we're selecting rivers that touch it. And then if we want to modify that, if we want to clip them or do something, then we have to use different tools for that. Another challenge is that we might have data that aren't perfectly aligned. And so here's a challenge of scales, where we have some really coarse, maybe, I think these are congressional, or what is it? Let's see here. Okay, county boundaries are in brown. So it's really coarse data, and then kind of finer scale, finer resolution data, or these congressional districts. And so we want to make sure if we're using these two layers to select and do some analyses with, that we're choosing the right selection tool, because they're not going to line up perfectly. So we can't use this completely within because there's not good overlap. Maybe in this case, we just use an intersect tool, which is a little more coarse type of selection. There's also challenges of accuracy and precision. That's why, hey, I know this river runs through the city of Des Moines, but my points for identifying the location of Des Moines is actually not really accurate. And so it's not going to intersect with this line. So using something like, okay, it's within 10 miles or 1 mile or something like that, will give you that buffer and that flexibility, so that if the data aren't perfectly aligned because they came from different sources and you didn't match everything up perfectly, then you've got some flexibility there to select things. We can actually create a buffer shapefile. And so in the geospatial analysis toolkit, if you search for buffer, then you can create a new shapefile that's actually a buffer. And that might be something you want, a permanent shapefile, so that you can kind of use that to do different types of analyses. So if you search for buffer, it'll say, okay, give me a feature. It can be a point, line, or polygon. Name the output class, what's the linear unit you want to use, and then what method. And so planar would be just flat out. And then you have geodesic, which would be based on latitude and longitude. We're going to stick with planar just for simplicity. So some examples of this would be, give me a 100-meter drug-free zone around schools, and those might be points or a parcel. Here's a stream, give me a buffer off that stream where we're not allowed to log, and then export that shapefile. So you can't log within, say, 100 feet of a stream. So here's a shapefile of that buffer around the stream. And so that's a new shapefile that we can just use and map, or we could use it to do some additional spatial analysis to say, okay, tell me all the parcels or buildings that are within 100 feet of a stream, for example. There's kind of more than one way to approach spatial analysis, but sometimes having an actual shapefile to represent this buffer around the feature can be helpful. There's an option in the buffer tool, dissolve type. And that just means, do we want to bring it all together and lump it and kind of merge it, which would be dissolved, or do we want to keep it separate? And that would be basically anytime you have a separate element in your shapefile. So this is a segment of a stream. Here's another segment. We get a new shapefile or a new buffer. Just note that these, and I think we're going to do this for a homework assignment I'm going to give you to do over the next month. We'll be doing this kind of buffering. If you were to calculate the area of the buffers here, note that it would be much greater than what the actual footprint of the area is, because you're going to have separate shapefiles or entries for each one of these segments if you don't dissolve. Versus this gives you the actual footprint of the area. Now let's talk about actually modifying data based on spatial analysis. So before we were talking about selecting existing features, the river that goes out of Texas, the counties, you're just selecting them as they are. We have tools that can actually change the features. So clip works like a cookie cutter. and it extracts features, for example, roads that lie within a boundary. So here we have a road network for maybe the whole county or the state, and then we have the city boundary. And then we can use the clip tool to just clip and create a new shapefile of only the road network that lies within the city boundaries. So here's a little cartoon of that. Here's one shapefile, here's another shapefile. And if I clip this one based on this one, then here's my new clipped shapefile. It just takes an extraction or a cookie cut of the original shapefile based on some spatial information from the other. Erase is similar, except it cuts a hole. So it just removes everything inside. And so we could do the same thing where you say, I want only the roads outside of the city limits. So I'm going to use the city boundary to erase, and then you get a hole in the data. There might be some reason to do that, right? So clip and erase are some tools that we have. Note that we might have to go recalculate attributes. So say this road was one continuous element within the shapefile, and the length associated with that road was 2.7 miles in the attribute table, right? So that was calculated. We go and we clip it. The number in the attribute table isn't going to change. So it might be important to go back and say, okay, I'm going to update that and calculate the geometry. So there's this tool that you can do and recalculate it so we update it based on the new lengths. That might be important to follow. So just note that the data in the attribute table won't necessarily automatically update when you do these clips or erases or other amendments. Same thing for editing data. You can choose what features you want to select. So I'm going to go back to ARC to do that. So I'm going to clear this selection that I did last time. Let's just X this table out so we can see a little bit better. Okay. I got to find out how to do that. Let's see. By default, every feature list by selection panel on the contents pane. Okay. So if I want to say I'm going to do some selection of data manually, and I don't want to select the county boundaries, I don't care about the county boundaries, I just want to select the bridges, then I can go over here to my contents pane. And you see there's a lot of different options up here. Right now, this is just showing kind of the order of the shape files, how they're layered on top of each other. If I drag this down below, it'll disappear because it goes below the counties. So it's just the order, right? This looks at the data source. So which folders are these in? That might be helpful if you kind of forget where all your data are coming from. And then this is what can be selected. So right now, by default, everything you can select kind of any data source that's in here. But I don't want to select the county boundaries, so I'm going to uncheck those. And now if I go to select, I'm just going to select the bridges and not the counties. That might be something you want to do if you want to only kind of keep your life simple and only select the data that you care to do something with. So I only want to select these ones on the western slope, and then I want to export that and do something with them. So that's the selection option right here that I get at. Notice that it kind of went away when I drag that, right? You have the ellipsis, so you can look at that and bring that up. Okay. So last thing I'll say for this is that once you do a selection, you might want to, there's a lot of options you have. So I've selected the bridges that I'm interested in. I can make that selection into a new layer. And a layer is not a new shapefile, but it's just another way to present and symbolize information. It's just saved in the map. So you can make a new layer from selecting features. I can create a definition query based on that, or I can export them to a new feature data set. So for example, I've selected these bridges. Then I can, let's see here. I can export these features, and that would create a new shapefile based on just that selection. And then I can also do a layer. Let me just see where that is. So with that selection, I can go to under feature layer. This comes up whenever when you're kind of clicking on a particular shapefile. I go under data, and then I can do a layer from the selection. If I click on that, then it creates this new layer. And just note that a layer is not a shapefile. A layer is just something it's basically a copy. It references this data right here, it references the shapefile. But you can change the symbology and still you're not changing the original data. If I go to properties here, and then I go to source, I'm still in this geodatabase based off this table, right? This is the same data source as the original one. Properties, source. It's this table in the geodatabase. It's a feature class, right? That we created when we did display XY data. So this shapefile is the same. It's still the same shapefile, but it's just based on that selection. Then I can go in and change the symbology to reference something else. And so we'll make that as the west slope bridges, and here's everything else. And then I can go back and clear that selection so that now I have a layer that's based on the original data, original shapefile. I didn't have to make a new shapefile because, well, that could be clunky to go and export a new shapefile. I just wanted to do this for mapping purposes. And all this is going to be saved in the map project itself, as opposed to a new shapefile somewhere else outside of the map project. So a lot of options out there. To summarize, we can export to a new shapefile or save it as a layer file and just use it for mapping. So I save that map, and that is all we'll talk about for this lecture.